So when it comes to sequences, one other way that we can talk about them, although we don't use it too much in this book, is with curly braces, where we can either put the whole thing out as a list like I did with those Fibonacci numbers and put the braces around them, or with that AN in there, and then sometimes we might even put a subscript and a superscript to talk about the behavior of the values N, but really the AN general term thing works just fine, where we should think a little bit about the connection between these types of constructions and the types of things we're more used to. So say we have a function like f of x equals 1 over x, and that nice downward sloping inverse function, and understand that if we want to talk about that in the context of sequences, we can just take that same sort of picture, that same downward sloping picture, but remove some of the pieces of it. We take the discrete version of it to get our sequence 1 over n, where that 1 over n has a few special properties. It's called the harmonic sequence that we may see a bit of later, but it's important to get a sense of now, and it does give a nice picture about that sort of connection. And another thing that we might be curious about here, since we've talked about these general terms a little bit, is do we have a general term for the Fibonacci numbers? And we do, but it's not a very nice one. The one that we have that I'm going to talk about here is from a formula derived by the French mathematician Binet, which I believe used a method called generating functions. At least that's the method I used when I saw how it was derived. Maybe he had a different way of talking about it back then, but it's not the very nicest formula. It doesn't come from the very nicest place. Generating functions aren't the sort of thing you really may ever see, but, well, it is nice for completeness that when we want to describe the Fibonacci numbers, we use the name Fn. We don't have to call everything A, we call that F for, well, Fibonacci, but we have Fn is equal to 1 plus root 5 quantity raised to the power n minus 1 minus root 5 quantity raised to the power n over 2 raised to the n times root 5. How lovely does that look? Well, if you want to check to make sure that it does work properly, you just plug in some values n, but, well, it points out something kind of relevant for these, that we like nice patterns, and we have nice patterns, and most of what we're going to see are nice patterns, but the niceness of a pattern certainly isn't guaranteed. And sometimes when we have something like this, we may look at it and say, well, isn't there an easier way to talk about this in terms of previous values? Because the Fibonacci numbers were kind of built around the idea of getting one from the next directly, right? It's talking about rabbit breeding. That does happen in that nice pattern, although there are lots of other interesting things that happen with the Fibonacci numbers. You may see bits and pieces of them. I may link you guys to elsewhere to look for, but that's nasty. Shouldn't there be something better? And there is, which uses an idea called recursion that we're going to talk about next.